Hello students, in video number 20 uh, now we'll discuss about some catalytic properties of transition elements. But before I proceed further, let's have a chemistry joke. H2O is water and H2O2 is hydrogen peroxide. H2O is water and H2O2 is hydrogen peroxide. What is H2O4? My question is, what is H2O4? Think. It's simple, not much hard, just a simple answer. Okay, enough guesses. Let me reveal the answer. It is simply for drinking. Okay, I said what is H2O4? So H2O is for drinking. So that was a chemistry joke. Now we will discuss about the catalytic property of transition elements. Here we go. And transition elements and their compounds transition elements and their compounds exhibit catalytic properties. Transition elements and their compound exhibit catalytic properties. This is due to two reasons. This is due to one is this is due to their variable valencies it is due to their variable valency as well as free valencies on their surface. Now, due to variable valency, they offer more freedom or more kind of variety to the various substrate molecules. And due to free valencies, the substrate molecules may attach on their surface while the course of the reaction. So due to these two reasons, they show catalytic properties. Now, uh, when I think this you might have read in surface chemistry chapter as well, when transition elements when transition elements when transition elements are when transition elements are in powdered form, their catalytic their catalytic properties their catalytic properties will be exhibited to greater extent. This we can understand with the help of example. If this is the one catalyst of appropriate size, and further if I divide this into four small pieces, just four small pieces. So earlier the particles, if you say earlier the particles would have been there only on the surface, they came accumulated, the substrate molecule accumulated there only. But in powder form, apart from this already available surface, that was the already available surface, some new area will be generated, and that will be shown by some different color. If I show you this area which was not earlier available, not exposed to them because it was inside the bulk, but due to the breaking down, these new surface have been you can say generated. Now as a result, if you compare, now it has more surface area in small broken down form. Okay, so I can say here more surface area, it means it is going to be more powerful. Okay, so now further if we see transition metals and their compounds, transition metals and their compounds exhibit various catalytic properties as given in the table. So here is a table which I am going to show you, which is having the various example of transition metals showing their catalytic property. I think some of with some of them you might be aware. Now here see catalyst TiCl3 used as a Ziegler-Natta catalyst in the production of polythene. In the polymer chapter, we may see this, and I'll see you some of the familiar example which you might have discussed so far in earlier chapter. In Haber process, iron is used. Okay, Haber process where ammonia is being used. Now here see palladium along with nickel and platinum, it is used the hydrogenation process. Okay, from where vegetable oil is converted into vegetable ghee. I think you might have read in class 10th. And similarly some more example, you can say example of platinum, copper, nickel, Raney nickel process. Okay, you might have heard. So these are the various example you can see about the transition metal cation.